Next, I am going to explain what is the problem of gradient based method. So gradient based method is an algorithm that is used by computer and it is entirely different from genetic algorithm. This is not genetic algorithm, this is a different form of algorithm. Gradient based method means if the solution if this is an objective function, let x and y be any set of variables, and it is going to search for the most optimum solution. Optimum solution is a solution that will lie at the least point. So that let us assume that we have to find the minimum of this curve. That is going to be our solution. So in gradient based method, what it is going to do is once it reaches a point, it is going to check if what are the slope of the other 2 points right next to it. So if the values are increasing, it can understand that okay, this is the least value, so this will be the global minimum. But this curve has certain problems. All these points are also minimum values because the values next to it is also increasing. So once if say it is going to reach any of this point, these points are called as local minimum, whereas our actual solution is called as global minimum. So once it reaches the local minimum, our algorithm is going to check algorithm is actually going to think that okay, I have reached the minimum value, that is the solution, and it is going to get trapped over there. So it will get trapped in this value, and that is going to give us the solution as this is the solution of our problem, which is actually wrong. This is the right solution. This global minimum is the right solution, whereas the local minimum, where it is going to get trapped because it cannot come out of it. It is going to think that okay, I've reached the minimum value. So this is called as the local minimum, which is a problem. So in gradient based computer algorithms, gradient means actually calculating the slope. In such type of problems, this is a huge problem and it cannot come out of it. So in that case, genetic algorithm is going to help. So next we are going to see how genetic algorithm is going to come out of this local minimum. So for that, there is an operator called as mutation, and this mutation will prevent the algorithm to be trapped in a local minimum. So it is going to help you find what is the global minimum value or the optimum solution for a problem. So now let us see what is meant by mutation. In mutation, there are many methods. The first method is called as, so you're going to actually recover the lost genetic material from this due to crossover, and that is how it is going to help you come out of this local minimum. So first method is called as flipping. Flipping means, for example, this is like a mask that we saw in the crossover. So wherever there is a 1, the parent bit will be flipped and that will become 0. If the parent bit is 1, that will become 0. If the parent bit is 1, 0, then it will become 1. So that particular bit alone will be flipped. Here you can see that again this is a 1. So the parent bit 0 will be flipped to 1. So wherever there is a 1 bit in the mask, then there is a flip. And whenever there is a 0, then there won't be any flip. Whatever is the parent, that bit will be retained for the child also. So this is one method of mutation. Next is interchanging. Interchanging means we are going to select 2 random points and we are going to interchange the values between those 2 points. So here I am going to interchange between these 2 points. This 1 and between this 0, we are going to interchange and we will get the value like this. So randomly we are going to choose a position and then we are going to exchange between those 2. Next is called as reversal. Reversal means you can see that one point is chosen and the bit next to that will be reversed. This bit will not be reversed, the bit next to that will be reversed, and that is called as reversal. That is also another method of mutation. Then as we saw in crossover, mutation also has what is called as a probability. So this has to be defined while we are doing the genetic algorithm. In the algorithm it has to be defined what is the amount of, what is the probability of mutation that is going to take place. For example, if I say the mutation probability is 100%, then the entire chromosome will be changed. And if it is 0%, then nothing, no bits will be changed, nothing will be changed. So mutation helps the genetic algorithm from falling into local extremes. It can be minimum or it can be maximum. Next topic is regarding the stopping condition for the genetic algorithm. That is, the genetic algorithm will keep on going till we reach the best possible population or the best solution. So at some point of time this has to stop. So how will we know where to stop? So that can be done using a couple of methods. The first method is by giving the maximum number of generations that it has to produce. Say I give 5 times this has to run, that is 5 generations would be produced, and the 5th generation we are going to accept it as the solution. The next is the elapsed time, that is we are going to say that this algorithm should run for next 1 hour. So after 1 hour, what is the solution or what is the population that is available, that will be the solution. Next is when the fitness value no longer changes, that is whenever you're doing the next generation you are going to get the same fitness again and again, there is no change in that value. So you can understand that how many ever times that you're going to run, it is not going to generate any more new set of population. So that is called no change in fitness. So again we can understand it is time to stop. Then stall generation, if there is no improvement in the objective function or any length of the generation, then it's called that the generation is ultimately getting stopped. Then stall time limit, that is there is no improvement in the objective function during an interval of time, that is called as stall time limit. So whatever it may be, these are all indications that we can stop genetic algorithm and we can decide what is the stopping condition. So these are the some of the other method by which we can stop the genetic algorithm flow, which are the termination techniques. So one is called as the best individual. So best individual means let us assume that if an individual convergence criteria, it stops once the minimum fitness value in the population drops below the convergence value. We are going to set the convergence value, and if the fitness drops below that, we will stop. Then there is a term called as worst individual. Worst individual means when the least fit individual in the population have the fitness value less than the convergence criteria, that is called as worst individual. If we encounter a worst individual, then we have to stop. So all these are different methods how we can stop the genetic algorithm, and as I told you, we can decide which is the criteria. Next topic is called as the genetic neurohybrid system. So it is a combination of both neural network and genetic algorithm, and as you can see, this portion is the genetic algorithm. Starting from here till here is the genetic algorithm, and the fitness value or the best selected individuals are given to the artificial neural network, and the artificial neural network is able to learn based on the values that is given to it. So artificial neural network can decide a lot of things. So such combinations are good for very complex situations, but it has its own advantages and disadvantages as given over here. So in applications, it's actually used in face recognition, DNA matching, and to understand the behavior of various things. But it is a very complex procedure, and its maintenance is very high. So such combination of genetic algorithm and neural network are possible, but it has its own advantages and disadvantages. So you can read all this. Then next topic is called as the genetic fuzzy rule based system. So again here we are going to combine genetic algorithm along with fuzzy logic. Again this is also a new type of method which is an approach, and you can read the advantage, disadvantage, and as well as the applications related with it. Next, what are the advantages and disadvantages of genetic algorithm? Again, those topics you can just read. It is asked for a 3-mark or very short answer question that will be asked. Next topic is importance of genetic algorithm. So this I will explain. First thing, genetic algorithm can be used for solving very difficult problems. There are some problems which are called as NP hard. Those set of problems actually take years to solve. Even a computer will take very large time to solve such problems. So for such problems, we can use, it is actually a classification of a set of problems in mathematics. So such problems can be solved using genetic algorithm. And again, this is actually considered as an efficient tool in order to solve this in a very short amount of time. Then next is, there are certain other methods called as gradient based method. Gradient based method means I had explained about local minima and global minima and how genetic algorithm actually helps to recover from this method. So here, instead of the lowest value, we are going to consider the highest value. So this is called as the global optima. This is called as the local optima. So once it reaches the high value, when the algorithm is going through it, if it is a normal gradient based method means it will search what is the slope on either side. So if in both the sides the slope is decreasing, it can understand that okay, it is standing at the peak, and it will assume that this is the solution. But the actual solution may be over here. But since it has reached this gradient, it is going to assume that okay, I have reached the value. It is going to consider that I have reached the highest point. So okay, this is the solution, and it will stop and it will give you the wrong answer. But actual solution is actually lying over here. So using the technique called as mutation, genetic algorithm actually helps to recover from going into this local point. Instead, it will help to recover from that and will go to global point. So genetic algorithm will actually help wherever this gradient based algorithm is failing, genetic algorithm will help to recover from that using the method of mutation, and we can get the correct solution. So for such type of problems also, genetic algorithm is important.